The basic metabolic rate, BMR, refers to the amount of energy, in calories or joules, that an individual's body needs to maintain basic physiological functions while at rest. These functions include breathing, circulating blood, regulating body temperature, cell production and repair, and more. BMR varies from person to person based on factors like age, sex, weight, and genetics. It's important to note that BMR is typically measured for the whole body rather than individual organs or tissues. However, I can provide you with a general idea of how much energy different organs and tissues contribute to the overall BMR. Liver. The liver is a metabolically active organ and plays a central role in various metabolic processes, including glucose regulation and detoxification. It contributes about 27% of the body's BMR. Brain. The brain is a highly energy-demanding organ, despite its small size. It accounts for approximately 19% of the body's BMR. Heart. The heart is a muscular organ that continuously pumps blood throughout the body. It contributes about 7 to 10% of the body's BMR. Kidneys. The kidneys are responsible for filtering blood and maintaining fluid and electrolyte balance. They contribute around 10% of the body's BMR. Skeletal muscle. Skeletal muscles are responsible for voluntary movements. They contribute about 18 to 25% of the body's BMR, making them one of the largest contributors. Adipose tissue, fat. Adipose tissue stores energy in the form of fat. While fat tissue itself has a lower metabolic rate compared to other tissues, it contributes to overall BMR due to its mass. The percentage varies based on an individual's body fat percentage. Other organs and tissues. Various other organs and tissues, including the skin, gastrointestinal tract, and more, collectively contribute to the remaining portion of the body's BMR. To determine an individual's specific BMR, healthcare professionals often use equations such as the Harris-Benedict equation or the Mifflin-St. Jeor equation, which take into account age, sex, weight, and height. These equations provide a more accurate estimate of an individual's BMR, which can then be used to calculate daily calorie needs based on activity level.